to this concluding session of 6th NGGIBCI Conference on Crop Genomics Present and Future to celebrate the 10th anniversary of CAG. This time, the time has come to draw a curtain to our conference as we have come to the close of it. Last 3 days, we have had deep insight into several issues, strategies relevant for crop genomics. We had a great participation from all our delegates. Thank you very much to you all. Let me now start with today's proceedings and introduce our honorable guest for this occasion. First of all, I would like to invite Dr. S.K. Patnaik, IAS, to kindly occupy the chair on the dais. Dr. S.K. Patnaik is Secretary for Ministry of Agriculture and Agriculture's Welfare, Government of India. He has development experience in the disciplines of food and agriculture, horticulture, fisheries, watershed development, natural resource management, ecology and environment, socio-economic development of tribal vulnerable communities, administration of social sector schemes, creation of rural infrastructure, employment and welfare structures. Prior to being appointed Secretary for the Department of Agriculture, Cooperation and Farmers' Welfare, he held several positions in different departments. It includes his posting as Minister Agriculture, Embassy of India, Rome, and alternate permanent representative of India to UN agencies in Rome. Thank you very much, sir, for gracing this occasion. Thank you very much. Now I would like to invite Dr. R.S. Paroda to kindly occupy the chair on the dais. Dr. R.S. Paroda is an eminent Indian agriculture scientist, and at present he is Chairman for Trust for Advances in Agriculture Sciences. He is a former Director General of the Indian Council of Agriculture Research and Secretary, Department of Agriculture Research and Education, and Government of India. He was the General President of the Indian Science Congress Association during 2000 to 2001 and was the President of National Academy of Agriculture Sciences from 1998 to 2000. He was elected as the first chairman of the Global Forum on Agriculture Research, FAO, Rome, from 1998 to 2001. He has served as Executive Secretary of the Asia-Pacific Association of Agriculture Research Institution, APARI, based at FAO Regional Office, Bangkok. He also served as Chairman, Board of Trustees, ICRISAT, Hyderabad, and also member of IRRI Board, Philippines, and a member of Advisory Council of Australian Centre for International Agriculture Research, ACIAR, Canberra, and the Commonwealth Agriculture Bureau International, London. He has a long list of awards and honors to his credit. I will just mention two important awards here. These are Norman Borlaug Award conferred to him from the President of India, Dr. APJ Abdul Kalam, and the second one is the country's prestigious Padma Bhushan Award that was conferred to him by the then President of India, Dr. K.R. Narayanan. We are very much honored to have you present today. Thank you, sir. Now I would like to invite our Director General, Dr. David Bergvinson, to kindly occupy the chair on the dais. I introduced him in the inaugural session, so please join me in welcoming Dr. Bergvinson. Now I would like to invite Dr. Peter Carberry to kindly occupy the chair on the dais. Dr. Peter Carberry is a Deputy Director General Research at ICRISAT. Before joining ICRISAT, Dr. Carberry was Chief Research Scientist and Partnership Leader, CSIRO, DFAT Africa Food Security Initiative, CSIRO, Australia. His expertise in crop physiology and in development and application of system models. He is a key developer of the Agriculture Production Systems Simulator called APSIM, cropping system model, and that has been widely used worldwide. Thank you, Dr. Carberry. Thank you. Now let me invite Dr. Rajiv Varshney to kindly occupy the chair on the dais. We We all know about Dr. Vashne, so no need to introduce him here. Thank you again. We now have all our dignitaries on the dais. Let's welcome them formally with a big round of applause. To begin with, I request Ms. Swati to present a bouquet to Dr. Patnaik. Now I request Ms. Purnima to present a bouquet to Dr. R.S. Paroda. Now I request Ms. Swanika to welcome Dr. David Bergvinson. Now I would like to call Ms. Pooja Soni to welcome Dr. Peter Carberry. Finally, I invite Ms. Sadhana to offer a bouquet to Dr. Rajivash. Thank you all, ladies. Now I would like to invite Dr. Vashne to proceed further. Thank you again.
Thank you very much, Anu, and a very good afternoon to everyone. So, ladies and gentlemen, as Anu already introduced our dignitaries, I'm very pleased to see all of them here. They occupy or they hold very important position. They are very busy, having busy schedule. But despite of all these facts, they could make it. And especially I would like to mention our Secretary Agriculture for Government of India, Sri Patnaik sir, that he was very busy, but eventually on our request he made it. So sir, we are really grateful to you. Thank you very much, sir. And I would also like to mention about Dr. Paroda, and he's a big supporter of ICRISAT and mine as well, of course. And he's well-known agricultural scientist in the area of international agriculture. He, as mentioned earlier, he was the chairman of the governing board of India as well. And in fact, ICRISAT has named its gene bank after him, and our gene bank is called Rajendra S. Paroda Gene Bank. Anu mentioned about different award, and he just got very freshly award, and this was just 2 days before, and he got very prestigious award called the US Avasthi IFCO Award for his lifetime achievement in the field of agriculture development and agriculture research. Okay, so they are not able. Let me complete my sentence. Thanks a lot for that. Anyway, so what I wanted to mention that I was congratulating him last night, and I was saying, well, these awards should be very usual to you nowadays. Then he says, yeah, so getting award certificate is usual, but this time I also got the cash award, and this is 25 lakhs rupees. So this is fantastic. And then he mentioned that probably scientists should get those cash award as well. Generally, they get the medal or certificate. So it's always good to receive those kind of things. Anyway, so now I think we will be continuing our proceeding, and what we will do, that first we will be having the concluding lecture from Dr. R.S. Paroda, and we requested him to give his vision or views that how the genomics can address the sustainable development goal. And for this, I would like to request Dr. Paroda to come on the podium, and I will request all the dignitaries to please go down on the chairs again, and then we will reassemble. So please join me in welcoming Dr. Paroda for the dais, on the podium.
First of all, I'm grateful to the organizers for having given me this opportunity to come here on this campus which I have been visiting very frequently in the past. And for me, it is like homecoming. I congratulate also the organizers, Rajiv, David, Peter, and all others who had really put in the best effort to get the best possible experts and scientists on a subject which is of great relevance for Indian agriculture, especially in the context of improving productivity and ensuring food and nutrition security. I would like to also appreciate the presence of Sri Patnaik ji, who is a very strong supporter, because without the support for development, nothing would ever happen. And he is ensuring through National Food Security Mission that the concern of hunger is to the great extent addressed. Now, coming to the topic, it seems what in the program is slightly different than what was earlier given to me, but objective is the same. And in this, I'm going to talk to you about what future options are there for crop breeding and how genomics can help in that context. We all know that the breeding enabled the nations to progress through addressing not only the vertical expansion through improved productivity, but also through horizontal expansion by area coverage. This would have not been possible if we had not got breeding, like sugarcane. India is known globally for the sugarcane research and breeding, by which we call nobilization of cane, and it became possible to grow it, which was earlier a tropical crop, to also become subtropical crop. And throughout up to north, it could be taken up. Similarly, Gujarat never grew about 60 years ago groundnut. Today is #1 state. So it is all again due to varieties. If the varieties and technologies would have not been there, potato was never in the central India, but now potato is grown in central India, right up to Bihar and West Bengal. Whereas we used to think that it is a crop for only the temperate regions. Maize has gone to eastern India with very high productivity, and that too in winter crop. And soybean, there was no area 50 years ago in central India, and today we have more than 10 million hectare area just in soybean crop and has become #1 oilseed crop. So things have happened. Chickpea was a North Indian crop of long duration. It never used to be grown in central India and South India, and now due to efforts of breeding and especially of ICRISAT, varieties are there. I will talk about it later, where you now can grow it throughout India. And same way, pigeon pea was never a North Indian crop. It was always considered to be a long duration, wild and weedy crop, but it has now become an important crop for northern and western India. We all are aware, and I don't want to take more of your time, that green revolution had been through genetic improvement. And plants were earlier lodging. We made them erect by bringing in dwarfing genes, made them photo-insensitive, thermo-insensitive, and also brought in tolerance to the diseases and pests, and also responsive to higher nutrients, including water and fertilizers. Salt tolerance, deep water, all these were possible because of the technologies and through the breeding efforts of those times when perhaps biotechnology and genomics were not an important, understood as a science. I now feel that I should, after having attended 2 days program here, that possibly would have been better if I was plant breeder today. Because earlier it used to be, plant breeding a game of number. How many plants, how many you are able to screen, how many generations you are able to grow, and how many locations you are. So, but now you have sure process of identifying the required genes which can be incorporated in the desired background. So, and what happened? Just the Green Revolution led to a situation from an importing country to an exporting country now, is self-sufficient for food availability. That's another issue, that people due to poverty are not having access. So physical access is an issue, but physical access we have provided. Now it's an economic access which becomes socio-economic problem for us, and especially when we add every year one Australia to our population. Against fourfold, we could increase fivefold, and we are still continuing every year with this progress. Poverty got reduced, buffer stocks increased. We even never thought but started exporting to the level of 20 million tons. And our life expectancy when we became independent was 32 years. Now it is 68 years. It all could be possible, but then what happened? Often now it is being talked, and recent economic survey of India did tell that perhaps Green Revolution was cereal-centric approach. Green Revolution also led to more of problems like soil health, low organic matter content. Also the problem of macronutrient imbalance and micronutrient deficiency. Water table has declined wherever fresh water is being now used for growing these crops, especially rice and wheat. And also there had been greater increase in incidence of diseases and pests. So all these do require a new approach and new effort by the breeders, including the biotechnologies. And now we all know, despite all these achievements, when world leaders met in September 2015, they adopted Sustainable Development Goals, and still we are talking of no poverty, zero hunger, climate change resilience, also improving productivity and bringing in partnership. Let me tell you about partnership. I think partnership is the most important requirement for any success of initiatives, whether it is genomics or whether it is plant breeding. The Green Revolution would have not come. And I think in the previous panel, another issue also came of policy advocacy. So policy support, our leaders provided the best possible policy support when they went for getting the food and it was declined. Then I recollect I was that time just student and growing the seeds of Green Revolution at ICRISAT when Indira Gandhi said that do anything but not let your leader go and beg for food. And that's how when the Green Revolution took place and we had 5 million tons of increase in 1 year from 1965 to 66, it became Green Revolution. From there, still we have problem now of the malnutrition. When you look at global hunger index, India's situation is not all that good. It can be debated, but still it is quite low. It is almost around 95 or 100 number out of 117 countries, and the children below 5 years of age are all chronically protein energy malnourished. They need again to be provided nutrition. So it is not only for the breeders the challenge of increasing productivity for yield alone, but it is now the issue of quality. So we need to bring in better quality in our products, and that is the major challenge. And for that, there are options which we do see through genomics. So when you look at SDGs, and when I see what is the role of genetics, or genetics I include also biotechnology and genomic research and plant breeding, firstly, let this be understood that it is not biotechnology or genomics versus plant breeding. We will never succeed if this happens or this continues. And this disconnect has to be addressed very effectively and quickly. Secondly, that we have to increase not only yield, but also increase the quality of the products that we are interested in and bring in adaptation for climate change in the crop plants so that farmer is able to have his continued increased income. But then when you look back at crop breeding, I look back in my own life after 50 years of green revolution that there is complacency as far as plant breeding is concerned. It's not only in India, it is now globally in most of the developing countries. And this study was done by FAO, in which I was also involved, and it came out very clearly that if you do not give more emphasis on use of germplasm and have more plant breeders in place for research, possibly we will not be able to achieve the sustainable development goals. And for that, therefore, there was initiative by Bill and Melinda Gates Foundation, about which I will mention later, which is called Global Initiative on Plant Breeding. So this is the global initiative of plant breeding taken up for last 1 decade, and effort is to ensure that the plant breeders are able to have better capacity building, programs are strengthened, and partnership is ensured, and more of genetic resources are used. In this, when again I go back, there are slow genetic gains. I will show you some slides about work on wheat and rice. Less use of germplasm is taking place invariably at all places, including in India. Dependence on pre-breeding lines has become a kind of a rule, and most of the breeders in national system have become dependent on CG centers for providing the pre-breeding material so that they can have easy process of selection and release of varieties. Shift at one time was towards biotechnology, and people thought biotechnology will provide all the answers. And that's how I think the plant breeding went into the background. But we have to bring plant breeding back in forefront. As happened when Green Revolution occurred globally, donors thought that there is no problem now of any food or nutrition as far as South Asia is concerned. So whole priority went to Africa. But then again it had to be brought back that to address Millennium Development Goals, the FAO, the World Bank report clearly said that you have to give high priority to agriculture development as well as research. In this context then, lack of experienced breeders. So what actually is required in whole this process? Now we have to address these cross-cutting issues which are listed at the bottom. That firstly, whatever research we do, genomics good for good publications, good information, good insight, but genomics would not provide you the end product unless you have the innovation. And there will be no impact unless there is innovation. So whatever is required is, and this actually, once I had organized national conference on biotechnology, that why biotechnology, so much research going on, and we had laid a lot of emphasis in 90s, around 2000, then it came out very clearly that the biotechnology said, unless there is partnership with breeders in the public system or with the private sector, and especially for delivering the end product is very, very critical. So public-private partnership also emerged as an important area. But these are the two gaps which have to be addressed now by us together, not that all scientists working in genomics have to solve. The breeders also have to understand. and that's what is our future for. So what is the way forward? Way forward, looking at all these issues and addressing the concern for sustainable development goals, where partnership also is an important area. And if that partnership with IRI and CIMIT was not there, we would have not got the green revolution. Similarly, the initiatives are now taking place in case of pulses. The partnership with ICRISAT, ICARDA becomes very important. And we have to work hand in hand to see that these achievements are highlighted, and they are also seen as the new nutrition revolution rather than only green revolution. Now in this, when we look at, there is tremendous variability that is collected and conserved in the gene banks globally. Large number of gene banks, 7.4 million accessions. You need to have their characterization through genomic science. You have to go and see that they are the associating allelic value with phenotype is also addressed, and we have to see that they are finally useful genes are transferred to the elite varieties. For this, we had organized the first international conference on agrobiodiversity last year, which was inaugurated by Prime Minister Sri Modi. And it came out very clearly through Delhi Declaration. The global partners from all over the world had assembled there, and that there is an urgency to accelerate genetic resource conservation, not only conservation through use, which means you must evaluate, characterize, and make it available, not only just keep in the gene bank. So that is one part. And second is greater use of crop wild relatives, which is much, much lesser except in the CG system than in other national programs. And partnership has to be again for exchange, because exchanges have been affected adversely after the CBD and call for sovereign rights for genetic resources. So when we look at this FAO second report on the state of the world PGFRA, for which I also wrote 2 chapters, we find that, national systems are mainly now depending on breeding lines, which means the pre-breeding materials which you are giving, but very little use of wild species which you see. Whereas the CG centers and the advanced NARs seem to be addressing it well, and private sector is laying more emphasis along with the CG centers for land races and their use. So we have to address these again more critically and see how this scenario can be changed. Then comes the question of what should we do, how we make the science and the information that is being generated or knowledge that is being generated to become an end product. And that's why translational research becomes an important requirement. Sir Gordon had given this terminology and said that there is no use of coming with more of technology and research papers published in refereed journals unless there is the end product which reaches for the benefit of the smallholder farmers. So for meeting the sustainable development goals, we have to elevate this game of scaling of innovations, and that too through crop improvement. And look at, this is the innovation which happened in US in maize breeding. In India, we were told that for you, composite and synthetic approach is sufficient because you won't be able to take care of production of hybrid seed. So we were advised to go only for a second level approach, for which they had changed in 1950. So we were 50 years left behind to take benefit of this technology, where they had gone to the level of 7 to 8 tons. And our production in maize in India remained till 2000 only 1 ton average. So how could you have this divide? And this technology divide was when I talked to the private sector people, why you are not coming? Because there you are doing all this business for hybrid. In these countries, even China had gone ahead and utilized this because they also had more than 6 tons of average yield. And they said that you don't have plant protection right, and you don't have also the secrecy maintained, or so there is a question of piracy. So, sir, we cannot bring this technology. So we started doing research ourselves and strengthened, and a special program on hybrid was initiated, and then see what happened. We released the first single cross maize hybrid in around 2000, and in 1 decade, the maize production doubled. Then we also saw to it, because policy support is required, so we brought in the Plant Breeders and Farmers' Right Act also. Gave high priority to it and brought it. So then private sector from outside started coming, and now they are providing more seed than even the public system. And productivity also increased. So from 10 ton to we went to the 20 million ton. Our productivity increased from 1.5 to 2.5 million tons per hectare, and it showed the fastest growth. Today also among cereals having the fastest growth in entire Asia. But now what you need is through use of geneticists and biotechnologies, the facilities and approaches which can accelerate this process. So acceleration of this process through double haploid technology has enabled in Africa. Now Prasanna has left, but this is his slide. About 30 or 40 Simit hybrids have been released there, and we in India is still thinking of creating this facility. So we have to really accelerate. We have to provide the environment. We have to strengthen the breeding. We have to bring in linkage with the biotechnologists and the plant breeders, and see that you have a goal and you work for that goal, not for endless goal for publication only. So this is what is more important. So we must have priorities first fixed, and then have the research program accordingly. These are the kind of facilities. Now we are thinking of building this facility. Now again, scaling. With great effort at CIMIT, they were successful in breaking this negative linkage through the breeding and through the evaluation in their biotechnology lab, for which Vassal and one Mexican scientist got World Food Prize. There is a success of QPM, but now it is still not picking because there is still a yield penalty. Yield penalty of about 10%. So either there should be higher price for this, because otherwise this is a very good product, and on other side we have protein requirement to a greater extent, and the other requirement also is that we need to make this much more attractive in terms of its quality improvement, which I said in the beginning. So it is not only QPM, but it is also through the partnership with the private sector, double haploid technology and biofortification to go in for either provitamin rich, vitamin E, iron, zinc, methionine, and so on. And then only we will be able to, like, we have higher price for basmati rice than normal rice. So unless that policy support is provided, technologies are there, but they will not pick up. So we require some really out of box thinking in these directions, because what happened in case of rice, when we went for this hybrid rice conference in Changsha, including ERI people were not aware that China had 50% area under rice, and each hectare they were harnessing 1 ton extra yield just by one technology. So Out of 30 million hectare, now we have 43 million hectare in rice. And we started also research ourselves. We brought this father of the hybrid rice from there to Hyderabad, I think 4 times at our cost, and requested him. He won't give the material, but we requested him to train our people. And that's how today we have 3 million hectare area. But 3 million hectare area in last 20 years. How many years we will take to have 10 million hectare? So where are we? What are we doing? Where are our priorities? Are some of the issues which have to be thought of. And when you look at area under hybrids, I said that if under maize, area is increased under hybrids, and for that we need enabling environment to support private sector, because they are the people who will deliver. But if they produce hybrid seed, there is no support. If government system produces hybrid seed, there is subsidy. There is a disconnect. So we have to see that somehow that encouragement incentive is provided, and if we can increase from 60% area, which is currently, to even 80 or 90, we can double this maize production in next 10 years. Another approach, we were told in the beginning, now there are a lot of advancements and genome maps are available in most of the crops. We started with rice. India, our partner, we took part very actively at that time, and we were told that marker-assisted selection will help. But there are very few examples. This is the ICRISAT work on marker-assisted selection, the first hybrid through marker-assisted selection, which was converted as downy mildew resistant. So you have better resistance in it than the original hybrid. So you have several such kind of good varieties. These genomics should try to help us to improve the deficiencies of those materials which otherwise earlier was possible. The kind of work which Dr. Khush did, you find very few examples of such breeders having dedicated their whole life. I see here Nigam also sitting, dedicated whole of his life to groundnut. So you need some of such people who continue working and doing, and this kind of pyramiding, and this kind of pyramiding is now possibly more easier through genomic research than before, which was not. So earlier it was number game through which we were trying to bring in. So there are opportunities. These are again, I think, there's a slide from Rajiv. Most of the crops have been, these genome sequences are available. We have information. We are also aware that now you can target genes and go for designer crops, whether it is rice or whether it is pigeon pea, and high value genes can be incorporated. But then where are these examples where these materials have been made available for higher productivity or better use? There is also concern now that we should have varieties which can respond to low inputs. There is also concern that we should have varieties which are responsive to less of water or drought or to heat tolerance. Now all these require definitely a targeted effort and approach. And we have to see that this curve which was earlier, this curve if you look at, this curve earlier till 2000, this curve was 1 ton. But after 2015, the yield declines, 1 ton increase, 100 kg per hectare increase has now come down to 78 kg hectare, which means there is definite now decline, and possibly you would require some new approaches to improve the wheat productivity, whether synthetic wheat or whether you go for approaches like
Phenotyping, recently phenotyping facility has been inaugurated by Prime Minister at Delhi, and this is at Ludhiana through CIMIT program. You can now have such possibilities for evaluating large number of germplasm lines, which otherwise was not possible before. You can use the wild and weedy materials for going in for synthetic materials, like what has happened in case of wheat. They started this synthetic program, I think, 3 decades ago. One of my colleagues and scientists has even retired from there, was from Pakistan, Mujib Kaji. And the materials are now available, but none of them really came to a production level. But then they have better resistance, they have better tolerance, they are also good in their nutrients, zinc, iron, etc. And now CIMIT has started taking advantage of this, and there are breeding lines which are being made available to national systems through pre-breeding. Hybrid wheat. Many people did research. In India also we did. We had hybrid by private sector. Now you see recent decision in Europe. Several private companies in Europe have decided very clearly to reduce their investment in pure line breeding and have initiated the work mainly relating to hybrid, because they do see an opportunity for better profit and marketing. But currently the increase is only 10%, so that possibly is not economical. So they have to elevate the game. Biotechnology. Globally, many countries, including India, have taken advantage of it, and I don't have to go into detail of this slide. You all are very familiar, and more than 185 million hectares covered today in several countries, many developed and developing countries. We knowingly provided the enabling environment for its release and testing, and it was released in 2000-2001. That's the time when I left ICR. And see what has happened. I don't have to say what has happened, but now we have become exporter of cotton. Now we have reduced our pesticide load by 40%, and we have helped the poor farmers to 5 million cotton farmers, and we are now exporting to the level of 3 to 4 billion US dollars per year. But when we have now products for GM food crops, we have policy paralysis. We have, if we didn't have the BT cotton released, possibly we didn't have any case to argue. At least we have they say that taste of pudding lies in eating. So at least we have tested what biotechnology can do. But the people who are standing against it on road are quite ill-informed, and there is less of public awareness. And also we are struggling for a genetic divide, because there is potential, but we are not able to harness. We have to increase productivity. We have the largest smallholder farmers. 80% of our farmers are smallholder, less than 2 hectares of area. And we have to continue feeding people. We will have to increase our food production by 70% by 2030. From where it will come? It is not going to come from organic farming alone. It is not going to come by traditional approaches. And when you can definitely also reduce the pesticide load, which also is an environmental problem. So that aspect has to be seen. And how much evidence it will be required, which will be enough evidence to convince. So there is, I think, some disconnect there. We are all working, struggling, and sometimes even going to Supreme Court and arguing, but possibly one day, and that's why there is hope that we should continue. And I am told that
Now there are students in the universities who don't want to work on transgenics. So I don't know what is your experience, but this is what is happening. So, and from where you will build capacity, you need capacity also on the other side. Now the gene silencing or genome editing, all these new technologies have come, and people are very enthusiastic about it. I hope it will help. It will solve the problem of the GMOs, and we will have alternatives available. But how long will it take? And I'm still not clear whether the technology which has come is in public domain or will be available for public research. So again, question of patenting would be there. Nutrition, several crops, and once this Harvest Plus program started globally, we found out that there is tremendous opportunity to increase the quality of our products, and there is deficiency in many areas for iron, zinc, manganese, and so on. And so several of these, and this group under Professor Boyce got the World Food Prize 2 years ago. Final aspect of mine is about, so one is yield increase, quality improvement. The third is on the climate side. On the climate, it is now clear evidence of last 6 to 7 years of research at various levels that there will be an impact adversely to the extent of 7 to 10% on different crops. But this has to be addressed through better breeding and biotechnology approaches. Like what happened here. It was not biotechnology that time, but it is the work of ICRISAT, which I mentioned to you. A crop which is about generally known as 120 to 150 days, you made it 75 to 80 days crop. And that's how you could grow it in Coimbatore and in Tamil Nadu. That's how when you could come to the central India, 85 to 90 days crop. This is adaptation. And for this we have tremendous opportunity and germplasm and genetic resources available. But they need to be studied and they need to be used. Such studies cannot be done by just saying. Everywhere we are told that agriculture contributes about 13 to 15% to the greenhouse gas. So our load from agriculture is around 13 to 15%, and maximum from that is either through rice or through bovine animals. In rice, it is methane emission because you are flooding and growing rice all through, and the nutrient use efficiency is not much. We have to improve the nutrient use efficiency through biotechnology. We have to also see this kind of research which Japan has done. Continuous flooding, this is the kind of methane emission. You reduce the flooding by 7 days aeration. This is the reduction. You again reduce it by 14 days. This is the reduction. And then when you reduce it by 21 days, which means, say if the crop season is there of 120 to 150 days, 1 week after every 3 weeks, if you have that kind of gap, you could possibly eliminate it. But then what would be its effect on yield has to be also seen. So it requires thorough research. And whether there are genotypes which can withstand this kind of aeration. And now we are talking of aerobic rice, direct seeded rice. So there are options available, but we have to expand the horizon of our research approach. And that's where biotechnologists and breeders, and rather I would say biochemists and pathologists, entomologists should all sit together and discuss and decide their priorities. That I think is not happening. That disconnect has to be thought of. Facility of this kind will be required if you are to do drought research. This is at ICRISAT again. But at how many stations and places these kinds of rain shelters are available? So you will require also the capacity, institutional, human, and technological built. This is the new approach which is going on, and it is not, I think those are all wise people. They have foresight. Monsanto are working for last 2 decades on drought tolerance, salt tolerance, and they have the material. Now what they are saying, inside the hothouse, it is not greenhouse. Inside the hothouse, please don't water, which means they have plant material growing with very less water. And this is what is required to be done. This is what is to be thought of. We must have foresight as well relating to, and very clear agenda before us as to what we are trying to address and achieve, and which is the team. An interdisciplinary, interinstitutional team is the only answer. Then finally, what is the roadmap? Roadmap is that we need to revisit and strengthen our All India coordinated program. They have become routine and weak. And All India coordinated program is the greatest success, I can tell you, of plant breeding anywhere in the world so far achieved. Never anywhere a breeder breeding variety in north, his varieties released in east was not otherwise possible. This is all because of sharing of germplasm, sharing of knowledge, working together, interdisciplinary team. But this program has become almost a routine for last more than 50 years, 60 years now, and this requires a revisit. We need to create centers of excellence for plant breeding where you have biotechnologists and genome scientists also present. Increase emphasis on effective use of germplasm, especially on crop wild relatives, which are available in our National Gene Bank. We have more than 400,000 accessions available, and of wild and weedy there are more than about 20,000. Now, but use of them is very, very little. And exchange has also gone down after CBD. We need to continue exchanging. Otherwise, if we would have not exchanged, our food basket would have been entirely different today than what we have. And for future security, for nutrition security, exchange is a must. So we must bring in the policy environment not to regiment and regulate, but to exchange and have more partnership globally. Greater emphasis on pre-breeding. Unfortunately, over the last 2 decades, even in the CG center, pre-breeding has been affected adversely. There are not more resources in the core fund, and that's why the effort is going down, because whatever is defined in CRPs is to be utilized. Mission mode effort on hybrid is required. The area coverage has to be enhanced. We need to promote GM food crops. How we can do, it's our own problem, but we need to sit and convince the policymakers, and I am sure policymakers listen, but probably message right is not reaching them, or there is some disconnect. Effective public-private partnership, I have been all the time telling, we have all the time considered private sector is still untouchable. And our seed sector has grown robust and through private sector. And why it became robust and in private sector, when they started, they didn't have their R&D. From public system, we took a conscious decision of providing free seed of the parental lines of all hybrids which were bred in our institutions and universities. Because we knew that these breeders will not produce seed and provide to farmer. This only will go through the private sector. And that policy alone made all the difference, and now there are several companies who have their own R&D system created. And we must have more funding. And global conference when we organized in Montpellier and also in Uruguay, it came out very clearly that you have to reorient your agenda to the needs of smallholder farmers you have to change your research agenda from crop and commodity to farming systems mode, and you must triple your expenditure on agriculture research for development. At least 1% minimum of agricultural GDP should be spent on agriculture research for innovation and development. So now it is not agriculture research for development, but agriculture research for innovation and development. Then only possibly we will be able to have the yield gains for prosperity and prosperity for our future generation. Thank you very much.
Thank you very much, sir. So this was great lecture, and I think now we would like to invite all of our dignitaries to come please back on the dais.